Hello, this is episode 4 of How Hardy is Made, and we will look at the HARDI TurboFiller. This pesticide transfer system was introduced in 2007. It is a safe way of transferring liquid, granulate or powder into the main tank. The basic components are the metal frame, the hoses with fittings, a 25 or 35 litre hopper, a venturi nozzle that creates a suction at the bottom of the hopper, the control valves, a container rinse nozzle and a rinse gun. The TurboFiller name comes from the action at the bottom of the hopper. This unique feature makes it safe because powders and granulate cannot block it and cause overflow. The metal is laser cut, it is precise, and it doesn't heat deform the small components. It's fascinating to watch. Our Danish production cuts more than 1,500 tonnes of steel annually. Some steel is saw cut. Somewhat less fascinating to watch, but I'm glad I don't have to do it by hand. The robotic work centre has 6 tables, 2 transporters and usually 3 people to operate the lot. The items are placed and secured to the fixture table. The table is automatically queued for the transporter. A code on the fixture triggers the welding program for the TurboFiller parts. When it is back, the welded assembly is removed and the process starts again. Here you see some of the 180 fixtures used by this flexible manufacturing system work centre. The next process is the powder coating, which is then baked to protect the metal from corrosion. After a 5-hour trip on the surface treatment line, the parts are ready for assembly. An impact and scratch test is regularly done on the plates to check the quality of the hardened powder coat. The hoses for the TurboFiller need fittings. We start by cutting the hoses in the required lengths. The lengths are digitally set and the cutter does the rest. The rubber hose is for the high pressure circuit operating at about 10 bar. The low pressure transfer hose has the spiral reinforcement. A hot bath softens the hoses before mounting the fitting. All the metallic hose fasteners are made of stainless steel. When finished, the hoses end up in a wagon assigned to the sprayer sales order, which is then transferred to the TurboFiller assembly area. The hopper is made of polyethylene and a small amount of colour pigment. This is put into a mould that goes into an oven. The mould rotates while being heated to 260 degrees Celsius. After about an hour, the mould is cooled and finished. If you have ever made chocolate Easter eggs, then you know this process. The stainless steel cramps have a story of their own. They start life in a coil. It can be either 3mm or 5mm diameter wire. We started radial sealing our liquid systems back in 1985. It is a better sealing system than the traditional threaded fittings method. HARDI designed and made this machine to make the cramps. It can spit one out every 10 seconds and it does this about 400,000 times a year. The venturi nozzle creates a suction effect. After the lathing process and thread quality check, it is fitted inside a T-piece. The control valve consists mostly of injection moulded synthetic components. Here you see some of the 400,000 cramps in use to hold the components together. The icons make the functions easy to identify. Now we have all the TurboFiller components, and we just need to put them together. The sprayer model determines whether the TurboFiller is 25 or 35 litre in size, and whether the colour is grey or yellow. The assembly is now back in the wagon and ready to meet the sprayer chassis. The finished sprayer is ready for testing and then delivery to the customer. Now you have seen how we make the HARDI TurboFiller. We hope you have enjoyed this episode, and we hope to see you next time, where we will cover the dynamic fluid for liquid system.